Hey guys, welcome to the sixth lesson on behavioral health. Today we'll be talking about the feeling mind. First, I'll give a quick recapitulation on lesson 5, and then we'll talk about motivation and emotion, the two important points of interest for this lesson. Recall that we first learned about some terms regarding awareness, such as consciousness. We also learn about stages of sleep and the sleep-wake cycle, cycling between various brain activities, right, measured with the EEG, cycling through NREM and REM sleep, as well as sleep-wake disorders. And finally, we talked about hallucinogens, stimulants, depressions, and opiates. Please remember those. So essentially today we'll be giving you a breakdown of what is in the 7th chapter of the textbook, The Feeling Mind. First, motivation. Homeostasis is a phenomenon that can be applied to all sorts of things in nature. It's an observation that we tend to have a steady internal balance or equilibrium, and our bodies search for this type of equilibrium. Next, a set point is a value that is defended to maintain homeostasis. For example, body temperatures, fluid levels, heart rate, etc. Drive is a state of tension and arousal triggered by cues that are important for survival. For example, lack of homeostasis caused by a body temperature that is too high or too low. Drive reduction is the state of relief when you get rid of that drive from and getting rewarded, which is produced by the removal of that tension and arousal of the drive state. So you're back to equilibrium and you feel a sort of relief. An incentive is a reward that pulls an organism's behavior in a particular direction. For example, if I were able to give you 5 pieces of candy for finishing watching this video, then that would be an incentive for you to finish watching this video. There are two types of motivation, an intrinsic reward and an extrinsic reward. The intrinsic reward is one that arises internally, right? So think of self-satisfaction. It's based on personal enjoyment of a task or an activity. If you participate in an activity because you think it's fun, or you see it as a challenge that you want to be able to conquer, or you want to improve some ability and you find that satisfying. An extrinsic reward is one that's from an outside source. Take the candy. You might perform a desired behavior in order to earn a reward such as a better grade or praise, or to avoid punishment. The avoiding of punishment actually in nature is the extrinsic reward. So here, let's talk about hunger. So here are internal and external cues that motivate hunger. External cues include the time of the day, sights and smells that might make you feel more hungry, and social settings that encourage lots of eating. Internal might include stomach contractions, low levels of circulating sugars like glucose, right, in which case you'll need more food, and low levels of stored fats. Leptin is a hormone secreted by fat cells that help the body maintain an appropriate level of stored fat. There's a diagram to the left on this slide that basically describes this mechanism with leptin. So when fat levels are low, leptin levels are also low, and ghrelin remains active. Right? So ghrelin, remember the gr sound, that's like your stomach churning because you want to eat. So the eating behavior is then initiated, and then the autonomic nervous system is activated, so in this case, the parasympathetic nervous system is activated, and the body stores the nutrients. There is also lowered metabolic activity, and the hypothalamus Specifically, the lateral hypothalamus is what stimulates eating behavior. It's what makes you hungry, and the result is that the stored fat levels increase and the feeding stops once you've filled yourself with enough food and therefore your fat levels. Satiety is a sense of feeling full and not requiring further food. So within the hypothalamus, there are two parts, right? So there's a nuclei called the ventromedial hypothalamus, and its role is to regulate hunger and satiety, body temperature, fear responses, and sexual behavior. When it's damaged, and many experiments have been done on animals such as mice to confirm this, you have a lack of satiety, weight gain, and obesity can occur. Now, going back to the rats, actually, when you remove their ventromedial hypothalamus, they don't know when to stop eating. They actually don't know how to feel full. They just keep on eating and keep on eating until they physically cannot eat anymore and they die. The lateral hypothalamus is a nuclei within a hypothalamus which regulates feeding behaviors, inflammatory pain responses, sleep cycles, and autonomic function. When damaged, you have a lack of appetite and excessive weight loss. So think lateral for loss of appetite and loss of weight. Here's another diagram which explains in particular satiety. So when fat stores are high and leptin levels are high, remember leptin is the hormone that controls satiety, your eating behavior stops. Your sympathetic nervous system is activated once more, and your body expends nutrients. Therefore, you have a higher metabolic activity, and then ventral hypothalamus suppresses eating behavior, and then stored fat levels decrease, and then feeding begins. So essentially, what it's trying to tell you with the last image as well is that all these things happen in a cycle. You become hungry and then you become less hungry and then you become hungry once more from all the food and energy that's being expended by your body. Yerkes-Dodson law. So moving on to something other than hunger. So the dictionary definition of Yerkes-Dodson law it suggests that performance and arousal are directly related in the sense that an increase in arousal up to a certain level can help to boost performance. But once arousal exceeds the optimal level, performance starts to diminish. The optimal level of arousal may vary with different types of tasks. For example, taking a test, you need a fine balance between having some arousal, not having too much arousal and pressure such that you crumble and your performance decreases. Same thing can be said for high stakes sports, public speaking, performances, etc. You have to find the fine line and the perfect amount of pressure. So a moderate level of arousal allows for optimal performance, though this optimal level can vary based on the individual and the nature of the task. So recall those examples that I gave you. You need different levels of arousal in order to perform best for each of those tasks. They're not all the same, even within a single person and within different and throughout different people. For one thing, the level of arousal that's perfect for each specific individual will be different. BMI is body mass index, and it's a height to weight ratio used to identify healthy weight, underweight, overweight, and obesity. That's all you need to know about BMI. It's discussed very briefly in the textbook. Next, we'll talk about eating disorders. So, anorexia nervosa. You might have heard of Karen Carpenter, who is one of the first celebrities who had this eating disorder, who brought attention to it into the public eye. Unfortunately, she died due to her anorexia. Essentially, it's characterized by the maintenance of unusually low body weight and a distorted view of the body as obese. Their view is so distorted that many of their actions are self-destructive. They're so unhealthily thin some of the time, and they become illusioned, deluded by this type of by this type of expectation and uh, of what their body weight should be like. Anorexia itself literally means loss of appetite, and it's characterized by low BMI. Meanwhile, bulimia nervosa is a much more uh, elusive eating disorder because it's actually less detectable from the third eye, right? So bulimia nervosa is characterized by cycles of binge eating in which unusually large amounts of food are consumed and then purging through the use of vomiting or laxatives, right? So think B for binge eating and bulimia. These people have a normal BMI because they constantly purge out the massive amounts of food that they are intaking. Because they have a normal BMI, only they themselves uh, oftentimes know about their eating disorder. The thing is, this type of purging and then you're eating massive amounts of food actually is not good for your body at all, right? It messes up the electrolytes in the digestive system. So even though they look perfectly fine from the outside, you can have not just many mental health effects, but really physical effects of these eating disorders as well. It's actually very, very unfortunate for people who have to go through these things. Next, we'll talk about emotion. The autonomic nervous system participates in general arousal associated with emotional states. What that means is that there is activity of the sympathetic division of the autonomic nervous system, right? Remember, the fight or flight response to danger. It's under the immediate control of the hypothalamus. So that's one of like the most important, most prevalent examples for emotion. The hypothalamus is a brain region that has direct management control over that autonomic nervous system, but also it also participates in various emotional states. So here we have a diagram of the amygdala and the insula. So forget about the other things temporarily. Basically, they're regions located within the fold at the junction of the frontal and the temporal lobes, which are labeled on the image for you, and they aid in the identification of emotional stimuli and the initiation of arousal in response to the perception of these stimuli. Basically, what it means is that if you see a longtime friend which you haven't contacted in a very long time, you'll feel happy. But these parts of the brain will actually be able to help you identify the source of your happiness, which is your friend. So here we talk about these three parts of the brain: cingulate cortex, or the amygdala, and the basal ganglia. Let's focus on the basal ganglia. So the cingulate cortex serves as a major gateway between the amygdala and other subcortical structures and the frontal areas of the cortex. The cingulate cortex is the target of a number of pathways communicating information about physical pain, right? So all the pain arrives there. And the basal ganglia are large subcortical structures that participate in the generation of voluntary movement. This is what you need to know. These structures coordinate movements in response to emotional stimuli. There is a direct effect that the basal ganglia is responsible for in terms of this voluntary movement in response to the stimuli in your environment. Let's talk about Maslow's hierarchy of needs now. So here is a passage copied directly from the textbook. According to Maslow, every person feels a need to self-actualize, although many are limited in their capacity to pursue this need because of unsatisfied needs at lower levels. Maslow theorized that a person's highest motivational priority would be to fulfill the lowest level of unmet need. For example, a person who is both hungry, which is a physiological need, and lonely, a love and belonging need. Observe that love and belonging is higher up on the pyramid, so that's less of a priority. They would be more motivated to obtain food than to make friends and find love. So please associate Maslow and this hierarchy of needs with humanism, because you go from physiological to safety, then to esteem, and then finally you get to self-actualization, right? The interesting thing is many of the things listed under these categories can actually be perceived as happening simultaneously. For example, in real life, you may believe that you're being creative, but also have a need for love and belonging at the same time. This is like one of the most direct criticisms of this hierarchy of needs, although because it was very transformative, you will need to memorize it. Next, let's talk about some major theories of emotion. So A is where the perceived stimulus gives you specific physical responses, and then that physical response leads to subjective feeling. Next, perceived stimulus creates physical responses and a subjective feeling of emotion at the same time. The third process, perceived stimulus, creates a general arousal, and then using your brain, you assess your surroundings as well as your physical responses, which then leads you to a subjective feeling about what emotion you should be having. So the first one is called the James Lange theory, which is a theory stating that emotional responses occur as a result and therefore later than physiological arousal. The Cannon-Barth theory is the second theory covered 2 slides ago, and basically it's stating that physiological arousal and emotional experience in response to that stimulus occur simultaneously. Finally, there's two-factor theory, which is also known as the Schachter-Singer theory. It states that both physiological arousal and proper cognitive labeling of that arousal are necessary for an individual to experience emotions. So once you have that physical response, your brain, rather, needs to perceive those stimuli and also perceive your body's physical response to that stimuli in order to ultimately make a decision about whether the stimuli is good or bad and what emotion you should be having. For example, we take this bear. A stimulus causes the physical arousal. Now, this physical arousal could either be good or bad. For example, let's say that it's a large yell, but how is your brain supposed to know if this yell is a yell of in terms of excitement or if it's a yell in terms of danger and an exclamation of terror? Right? And then we cognitively label the physical response and associate it with an emotion. You see the bear, but you also associate your yelling with terror, and then you feel that terrified emotion. That is the two-factor theory. So, having said all that, if you have any questions, please leave them in the comments below and I will answer them. Thank you for listening to this lesson and we're getting all the way here. And see you next week. Bye.